Geometry, and we're looking at empirical and molecular formulas. So our learning intentions are to calculate the empirical formula when giving the mass of the products and the reactants, to calculate the empirical formula when given the percentage composition by mass, which we've met already, and to calculate molecular formulas given the empirical formula and relative molecular masses. So let's look at empirical formula. The definition for empirical formula is the empirical formula of a compound is the formula that gives the simplest whole number ratio in which the atoms of the elements in the compound are present. So glucose has the formula C6H12O6, and that's its molecular formula. But the empirical formula for glucose is CH2O, as this is the lowest ratio of the atoms of carbon, hydrogen and oxygen. Next, if we look at molecular formula, the molecular formula of a compound is the formula which shows the exact number and type of each atom present in a molecule of a compound. So, for example, glucose has the molecular formula of C6H12O6. The molecular formula of ethanol is C2H5OH. And the important formula here is that you can find the molecular formula by doing the empirical formula multiplied by N. So let's do an example. The question says glucose has an empirical formula of CH2O. Using a mass spectrometer, the molecular mass of glucose was found to be 180. What is the molecular formula of glucose? So the first thing that you need to know is that molecular formula is equal to empirical formula multiplied by N. So 180 is your molecular mass, and that's equal to the empirical formula, which is CH2O multiplied by N. So fill in for the CH2O and find its mass, and you get that 180 equals 30N, coming from the 12 from the carbon, 2 by 1 from the 2 hydrogens, and 16 from the oxygen. And then you divide both sides by 30, and you get that N is equal to 6. So from there, you can do your molecular formula is empirical formula by N. So the empirical formula is CH2O multiplied by N, which is 6, and that gives you C6H12O6. So just to do a comparison, the empirical formula, you're always looking for the lowest whole number ratio, where with the molecular formula, you're showing the actual ratio. The two of them can be the same. So C2H4 is the molecular formula for ethene, and C3H6 is the molecular formula for propene. But CH2 is the empirical formula for both of those, as it is the smallest whole number ratio. Where if you look at water, water is both an empirical and a molecular formula, as it cannot be broken down into simpler forms. We're going to look at ways to calculate the empirical formula, and there's two ways: using percentage composition by mass, which is discussed in the previous video, and given the masses of reactants and products. So to find the empirical formula using percentage composition by mass, you need to divide the percentage of each element by its atomic mass to give the number of moles of each element that's present. And then you need to find the simplest whole number ratio between the elements. So let's do an example. It says a compound contains 40% sulfur and 60% oxygen. What is the empirical formula? Now, I find that the easiest way to do this is to set up a table. So I set up a table with element followed by the percentage of it, the percentage divided by the atomic mass, and then the simplest ratio. So if we do it for sulfur, we can see that we have sulfur. It's 40%. Then we do 40 divided by 32, because sulfur has an atomic mass of 32, and you get 1.25. I'll come to the simplest ratio in a second. Then if we do the same thing for oxygen, you get Oxygen is 60%, 60 over 16 is 3.75. Now, to find the simplest whole number ratio, always divide all of your decimals by the smallest one. So you're going to do 3.75 divided by 1.25. So that's where this comes from. It comes from the 3.75 divided by 1.25, and this one, the 1 comes from 1.25 divided by 1.25. And that gets us a ratio of 1:3, so we know that it is SO3. So the other way to do it is when you're given the masses of either the reactants or the products, and this is usually called gravimetric analysis, and there's a very simple step to it. If you are given the mass of one product or reactant, we can simply subtract to find the mass of the other reactant. Is 3.175 grams of copper, reacts with chlorine gas, and 6.725 grams of copper chloride are formed. Find by calculation the empirical formula of copper chloride. So, if we write down everything we know that the mass of the copper chloride is 6.725 grams, and we know that the mass of the copper is 3.175 grams. So if we take them away, we can see how much chlorine gas was formed. So the mass of chlorine is 3.550, and that's gotten by subtracting the mass of the copper from the mass of the copper chloride. Once we know that, it's fairly simple to set up our table again with element, mass divided by atomic mass, the ratio. So if we look at copper, we have a mass of 3.175. If you divide that by the atomic mass of copper, you get 0.05 moles. And if we do the same then for the chlorine gas, chlorine has a mass of 3.550 in our question, and when you divide that by its atomic mass, you get 0.1 moles. So, as I said in the last video, you do the smallest ratio and you divide that into the bigger ones. So, the ratio of 1 here comes from doing the 0.05 divided by the 0.05 because it's the smallest ratio. And the ratio of 2 comes from doing 0.1 divided by 0.05. And then you can figure out your formula is CuCl2, because for every 1 copper there is 2 chlorines. So that's it for this video. Have a read through the learning intentions